Hello everyone. So this is a question from NEET 2026. Identify the incorrect statement from the following. Okay, so few statements are given to us and the chapters involved is P block and coordination compounds. Okay, so let's look into those one by one. So statement A says that nitrogen can form P pi P pi multiple bonds with itself. Okay, so first of all we need to understand what is a p pi multiple bond. So it is a chemical bond where a pi bond, obviously, because it is p pi, so it's a pi bond which is formed by obviously side by side or lateral overlap. So direct overlap leads to sigma bond and lateral overlap leads to pi bond, right? That, I mean, we know this. Okay, so this is a type of pi bond which is formed by side or lateral overlap of two p orbitals from two atoms. Okay, so this is pi bond formed by two p orbitals from two atoms. Okay, so with respect to diagram, I can show it to you, the p pi multiple bond. So this is an example of a p pi multiple bond where um, this p orbital is contributed by an atom, this p orbital is contributed by another atom. Okay, and also why is it a multiple bond? Because it can be either a double bond present on a double bond or on a triple bond, because we know that to form a pi bond first a sigma bond has to be formed, right? Okay, now nitrogen, because of its small size and high electronegativity, so nitrogen has small size and high electronegativity, it does form p pi multiple bonds with itself. So it forms p pi multiple bond with itself. Okay, so it exists as a diatomic molecule, we know that. So it exists as N2, and there is a triple bond between N and N. That is, in N2 there is a triple bond between N and N, and one of the bond is sigma, the other two bonds are pi bonds, and those pi bonds are nothing but p pi multiple bonds, because these pi bonds are formed by the overlap of p orbital from one n and p orbital of another n. They overlap and they result into the formation of p pi multiple bond. So therefore statement A is correct. Okay, one more thing, the other members of group 15, that is, for example, phosphorus, arsenic, antimony, so these guys, they don't form p pi multiple bonds. Very important, extra information. Other members of group 15, for example, phosphorus, arsenic, antimony, so these guys, they don't form p pi multiple bonds. Okay, that's because they have very large orbitals, and since the orbitals are large, so it leads to very less you know uh, effective overlap, because bigger orbitals leads to very small or less effective overlapping. Okay, so therefore they just form single bonds. For example, phosphorus combines with another phosphorus in a single bond. They will never form a multiple bond. For example, arsenic always combines with another arsenic as a single bond. Same thing applies to antimony, single bond. Only nitrogen can form multiple bonds, which are p pi with another nitrogen. Okay, so therefore statement A is correct. Okay, cool. Then coming to statement B. So statement B says that pC2H5 thrice and AsC6H5 thrice form d pi d pi bond with transition metals. Okay, so look at this guy. This is P, which is having a lone pair, and it is connected to C2H5, three of them. So you can see it can act as a ligand, okay, because phosphorus has a lone pair. And this guy is known as triethyl phosphine, okay. And in coordination chemistry, ligands have, abbreviations. So it is abbreviated in short as PET thrice, where this ET stands for ethyl, because C2H5 is ethyl group, okay. And this guy is, that is PET thrice, or you can say triethyl phosphine. It's a highly effective and a strong field ligand, okay. And next thing that we have to understand is, what is this d pi d pi bond, okay. So similar to a p pi bond, d pi bond is a bond where a pi bond obviously is formed by side overlap, since these are pi bonds, and the contributing or the involved orbitals are two d orbitals from two atoms, okay. So instead of p, we will have d orbitals this time, because it is d pi. And with respect to diagram, so we have, so these are d orbitals contributed by an atom, and these are, d orbitals contributed by the other atom. And you can see there is a bit of overlap, right? And this is, lateral overlap. So therefore this is an example of a d pi bond, okay. So due to presence of vacant d orbitals in the valence shell, phosphorus and other heavier elements of group 15 like arsenic, they can form d pi bonds. Very important, okay. So due to vacant d orbitals in valence shell, phosphorus and other elements like arsenic, so these guys can form d pi multiple bonds with transition element when they're compounds, for example, like p C2H5 thrice triethyl phosphine, we have already discussed, and AsC6H5 thrice, which is triphenyl arsine. When these guys act as ligands, then they can, when these guys are acting as ligands in a coordination compound, then they can form, the phosphorus and the arsenic can form d pi multiple bonds with transition elements, okay. So but nitrogen cannot, because nitrogen doesn't have vacant d orbitals. It's a, it belongs to the second period. It does not have any vacant d orbitals, okay. So if you want to look at the configuration of phosphorus and arsenic, phosphorus is neon 3s2 3p 3 3d0. You can see there are vacant d orbitals, okay. Also arsenic is argon 3d10 4s2 4p3 4d0. Again you can see there are vacant d orbitals, okay. So that's why it can overlap with the central atom in the coordination transition element, okay. So to understand this in detail, let's see using an example on how they actually form d pi bonds. So let's take an example of a complex where this guy is acting as a ligand, okay. So let's say the complex is NiCl2 PET thrice 2, okay. So this is the complex where our ligand triethyl phosphine is present, okay. The oxidation state of nickel here is +2, because the overall charge is 0. The charge of PET is also 0. Cl carries -1, so therefore x plus -2 is equal to 0. So the charge on nickel is +2. So therefore we know nickel configuration is 3d8 4s2. Nickel +2 configuration will be 3d8, and this guy, that is triethyl phosphane, it's a strong field ligand. So that's why it will cause pairing. And that's why the electrons in nickel will exist in this fashion. Okay. And also you can see how many ligands are there, two here and two here. So total how many electrons? Eight electrons. So eight electrons has to be accommodated by nickel. So therefore we need few more orbitals, vacant orbitals. So to accommodate 8 electrons, 2 will come here, 3, 4, 5, 6, 7, 8. So you can see the configure, the hybridization is DsP2. Okay, so it will have a square planar shape. Okay, now, so can you see the 3D orbital? These are, these are the filled metal 3D orbital, right? So these orbitals can overlap with an empty 3D orbital of phosphorus, which belongs to this ligand. Okay, and because of that it can result in a pi bond, which is a d pi d pi, since both orbitals involved is d. Okay, and this particular d pi d pi bond is an example of back bonding. It is known as back bonding because here you can see the metal is sharing these electrons with the d orbital of phosphorus. The metal contributes these electrons with the d orbitals of phosphorus. So therefore, this is an example of back bonding. Okay. So with respect to diagram, you can understand it better. So let's say we have nickel. So these are the d orbitals of nickel, and these are, to be specific, the filled 3D orbitals of nickel. Okay. This is what I'm talking about. So these are the orbitals which carries these electrons. Okay. And obviously we have the ligand, which is triethyl phosphine, that is this guy. So this guy has phosphorus, and this phosphorus has vacant d orbitals. So I'm showing it in this fashion. So these are the empty 3D vacant orbitals, and you can see both are 3D 3D. Okay, so these guys, they can overlap, resulting into something like this. So you can see this is the overlap, this is the overlap. So this is what is known as a d pi d pi bond. Okay, and also you can see why is it an example of back bonding, because filled nickel is sharing its electron back with the ligand, with the empty d orbitals of the ligand. That's why it is known as back bonding. And because of these reasons, B is a correct statement. So it's a correct statement. Okay, now coming to C. C says that phosphorus, arsenic, antimony shows catenation. So catenation, we know it is self-linking of numerous atoms to each other. So it's a correct statement. Okay. So among the elements of group 15, phosphorus has the maximum tendency for catenation. Okay, because when it forms bonds with itself, for example, phosphorus combining with itself, the resulting pp bond strength, this bond, is high. So to be specific, it is 213 kilojoules per mole. So this tells us that the whenever phosphorus links to itself, the bond formed is strong and stable. Okay, so therefore it shows maximum tendency for catenation, and nitrogen has very little tendency for catenation, because the NN single bond, let's say it forms, it shows catenation, the resulting NN single bonds are very weak. To be specific, the bond strength is 159 kilojoules per mole. Okay, and so you can see it's not a very very stable or a strong bond. So therefore nitrogen has very less tendency, but the other elements of group 15 has high tendency to show catenation. That's why it's a correct statement. And nitrogen has very less tendency to show catenation, because there is a lot of inter-electronic repulsions between lone pairs of electron present on an atom. So if you can see, so there are, so these guys will be, repelling each other. And also nitrogen is a small size molecule, small size atom. Okay, so therefore there will be a lot of repulsions going on, due to which, it won't refer, or it won't prefer to show catenation. Next we have statement D, which says that nitrogen can form d pi p pi bond with oxygen. Okay, so to form d pi p pi bond, there should be lateral or side by side overlap of d orbital and a p orbital, right? So therefore, nitrogen and oxygen, either of them should be having, d orbitals. Okay, so when we look at nitrogen and oxygen, they both belong to the second period, and their configuration is: nitrogen is 1s2, 2s2, 2px1, 2py1, 2pz1. You can see there are no 2d orbitals. I mean, 2d orbitals does not exist. Similarly, oxygen, 1s2, 2s2, 2px2, 2py1, 2pz1. Again, 2d orbitals does not exist. So both atoms don't have a d orbital at all. Okay, which is either filled or empty. So there is no d orbital at all to, overlap with a p orbital. They do have p orbital. Okay, so therefore statement D is incorrect. Okay, to form a d pi p pi bond, we need d orbital in at least one of the atom. It can be either filled or empty. Okay, so therefore the final answer is, so they are asking us the incorrect statement. So therefore D is the incorrect statement. Okay, thank you.